Hi students, welcome back. Let's continue with these distributed models. So far we had seen the architectural models. The architectural models are of two types. One is the client-server model and the peer-to-peer model. Now let's see the fundamental models. So there are three different types of fundamental models. Let's see one by one. The first one is the interaction model. Interaction model means it is going to communicate how the systems are going to be communicated. Actually, according to I said the distributed computing models are of two types. One is the fundamental architectural model and the fundamental model. So architecture model deals with the organization of component across the network, whereas the fundamental model is completely based on the some fundamental properties like characteristics and failures and about the security. So these fundamental models, these are all called as a fundamental properties of a system. Okay. So in that, the first model is the interaction model. The interaction model, the computation occurs within the process. So it deals with whatever the computation that is occur within the process, how it is going to be interacted. The processes interact by passing messages results in communication, that is the information flow, and the coordination. So the process interacts by passing messages which yields a communication and the coordination. Communication means it's just an information flow. Coordination means it's just a synchronization. There should be a synchronization between the two systems or two processes. Okay. A synchronization and ordering activities between the processor. So the thing you have to remember that to interact within a processes, there should be a communication and the coordination. Interaction model reflects the facts that communication takes place with delay. Here the performance of communication channel, I said if you take any process, how the performance of that communication channel will be established. It's based on the latency, bandwidth and the jitter. A latency is nothing but as a message, what type of messages we are using, what type of network and the system, and the bandwidth of the system, the channel and the jitter. So the performance of that communication channel depends upon the latency, bandwidth and the jitter. There are two variants of the interaction model, that is a synchronous and asynchronous. If you take the synchronous distributed system, it has on. The process is executing in a known lower or upper bounded time, that is one point. The message is received within a known bounded time and known local clock drift rates are present in this synchronous data systems. Then what about this asynchronous data distributed system has no bounds on? Suppose if it has no bounds on, the process execution speed is there, message transmission delay will be there and the clock drift rate will be there. So this is about the interaction model. And the next fundamental model is the failure model. The failure model defines and classifies the faults. If there is any faults in the systems, that this failure model is going to be defined. It is important to understand the kinds of failures that may occur in a system. So it is very important what type of failures that are occurring in the system, that you should be aware. So this is one of the important concept in the fundamental model, that is a failure model. So the different failure models are fail stop, crash, omission, arbitrary and timing delay. Suppose fail stop. The fail stop is nothing but whenever this fail stop is occurred, a process halts and remains halted. Whatever the process is going on, that is going to be halted and it becomes ideal. Then other process can detect that the process has failed. So whenever the fail stop is there, the other process is going to be detect that failed process. Suppose if the system is crash. A crash, a process halts and remains halted. So whenever the crash failure is occur, it is also going to be halt and remain halted. The other process may not be able to detect this state. So here whenever the crash failure is occur, the other process may not be able to detect this state. Next failure model is the omission. A message inserted in an outgoing message buffer never arrives at the other ends in incoming message buffer. So omission is just type of message that message is not able to receive at other side. That is one type of failure. Arbitrary. Here the process or channel exhibit arbitrary behavior, that it may send or transmit arbitrary message at arbitrary times, commit missions. A process may stop or take an incorrect step. And another type of failure is a timing failure. The clock drift exceeds allowable bounds. Okay, so this is about the failure models. Now let's see the another type of the fundamental model, that is a security model. There are several potential threats a system designer need be aware. That is the threats to processes, threats to communication channels, and denial of service. So these three are the security models. Threats to process means an attacker sends a request or response using false identity. And threats to communication channel means an attacker may listen to message and save. We call it as eavesdropper. Denial of service. In the denial of service, an attacker may overload a server by making excessive requests. So these are the three different security models. The threats to process, threats because of communication channels, and the denial of service. So the cryptography and authentications are often used to provide the security. So these are all the three different fundamental models. One is the interaction model, failure model, and the security model. Thank you.